Howdy, hidey, ho there. But that did not come out right. That did not work. All right, try that again. I can't remember that. It's Ned Flanders. I can't remember his line. Hello and welcome to another edition of Tech Deck Karaoke. And this week we are joined by Reuven Cohen, who I must say has a propeller that spins about as fast as I've ever seen. We brought Reuven in recently, maybe 6-7 months ago, to give us some help and guidance in the space of AI. And myself and my top engineer sat on a call with Reuven and man crushed very hard. This guy knows his stuff. He moves fast. He thinks quick. And I am in over my head for this episode. So Reuven, welcome. Please introduce yourself a little bit to our audience.
Yeah, well, I appreciate you taking the time to invite me to this. This is a great thing. I spend a lot of time doing presentations, so a karaoke presentation for tech decks is about as great a structure as you're going to get for me. I'm basically a reformed cloud guy, now AI guy, right? I've evolved from being infrastructure to intelligence. That's really what you need to know. I think the presentation will take care of the rest. Thanks for including me.
Absolutely. And just for a little clarity, and because I know you're a very modest and humble person, when you say you evolved from a cloud guy up, you were a deep infrastructure guy that was part of the development of the very early phases of what we now all know and love as public cloud computing. And now you've shifted headfirst into AI. Is that fair?
Yeah, I think, the claim to fame, if you will, early in my career, I've been doing this for a long time, but the parts that probably matter most are in 2003, I came up with an idea that I called Elastic Infrastructure as a Service, which is a mouthful. And that was a while, people are like, no one's going to want to outsource their infrastructure to someone else's infrastructure. That makes no sense as a utility, no less. And what's a hypervisor? And so I hooked up with the folks at, Cambridge, and the project called Zen, and that was SourceForge project of the day for those old enough to know what SourceForge is. And a few years went by, and the folks at Amazon called me up and said, "We like what you're doing with this infrastructure stuff. Can you help us?" And the rest is history.
Oh, that's interesting, and I understand why no one would want to buy Elastic Infrastructure as a Service, because nobody wants to spend money on EAS.
Yeah, exactly. Yeah, I had one of the gimmicks we had in the company once was a pair of boxers that had IaaS on the backside of the boxers, and a little kiss. You get the idea.
Yeah.
Excellent.
I like where this is starting. I'm very happy about this.
We're also joined by Ms. Sabrina Schaefer. Good morning, afternoon, or evening, Ms. Sabrina.
Hello. Yes, I'm here for another completely impartial episode. So I'm ready to bring it. Reuven, we're ready for you.
Well, brilliant. Without further ado, I'm going to be jumping into Reuven's slide deck for the first time, presenting it to you at the same time I'm seeing it for the first time. The only thing I do know about the content that I'm about to present is that there are a lot of content-heavy slides, so I'm going to move a little faster through this than my normal pace. So that we can get through the meat of the presentation, but more importantly, get to the guy that knows what he's talking about so you can learn something coming out the back end. What we're going to be talking about is an introduction to agentic engineering. So when we're talking about agentic engineering, we're talking about utilizing AI in an agentic model. We're talking about reimagining the way we're using this intelligence. And we're talking about building in more autonomy and interaction into our AI projects. So as we move forward, looking at this, we've already got our introduction from RuV here. So RuV is somebody you should definitely reach out to if you're in this space. He works heavily and extensively within the Fortune 100s to help them solve big problems with their business mission or challenges utilizing AI and AI tools. But the agentic approach is part of how he delivers what he delivers to his clients. So if you think about it, one of the things I love about the way Reuven works and the way AI can help us do our jobs is Reuven is eating his own dog food as he's learning, progressing, and driving forward his consulting practices. So as he's bringing all this together, he's using AI to deliver better results, bigger results, more extensive results, both internally within his process and with his customers, going through anything from the consulting and expertise through the strategy, transformation, architecture, and Copilot usage and the rest. He works with a slew of clients you may or may not have heard of. Some of these are really unknown, like the Microsoft and AWSs of the world. So if you're not in those niche spaces where you've heard of those logos, you could go look them up. But long story short, let's move forward into some content. What are we talking about while we're looking at agentic engineering? What's the introduction to this? What we're looking at is the core components of building intelligent agents utilizing AI tools, how we can utilize different agents together and their unique capabilities, the key considerations for designing these systems in an agentic model, meaning we're going to use multiple agents to deliver an outcome, and then some real-world applications. So with the introduction to agentic engineering, what we're going to start with is defining agentics, because that is going to be the first chunk of information your brain will need to move on to the next chunk of information, and that's how learning happens. So the field of study in engineering practice focuses on creating intelligent systems that can be proactive. Now, that is a term that gets thrown around a lot. We talk about proactive versus reactive, and I want to get you proactive versus reactive, and da-da-da-da-da. But when we're talking about proactive, we're talking about AI being able to make intelligent decisions, operations, or analysis prior to you telling it exactly what to do. Think about a really intelligent person on your team that can come up with their own ideas. That is a proactive person. We're moving in that proactive direction. We're also looking for these systems to be autonomous, meaning they can work on their own without as much prompting and direct human engagement. We also want them to be collaborative so that these agents can work together on their own specific pieces of a task while those pieces all come together into the beautiful puzzle of an outcome you're looking for. And we also want these things to be targeted, where they're pursuing defined objectives with guardrails into how they're working. So these four components are the basis of how we look at agentic engineering, at least if I'm making this up correctly as I go. The packed agentic hierarchy really breaks this down into a little more detail. We're still looking at the same things up top with examples of the outcomes on the far right box here. But underneath that, we're looking at the proactive system being context aware, providing adaptive strategies, right? We're looking at the autonomous system being able to have self-improvement, where it can learn and improve its own processes internally as it creates the data of doing its job. We're looking at it to be collaborative, wherein we can take an emergent collective intelligence and have it work together using things like basic API calls. And we need it to be targeted, where it's not general purpose, not necessarily general purpose problem solving, but it can do complex problem solving, multi-step task execution, so on, focused in a more single focused task. So finally, we get into some examples. We get AGI, the theoretical, this is intelligence like humans deliver, right? An ability to have a widespread artificial intelligence or an artificial general intelligence. We've got things like the advanced AI and LLMs. And then if we get all the way to the bottom of the list where it wasn't proactive, it wasn't autonomous, it wasn't collaborative, we have traditional software. So we're moving up this stack. And that's what we're talking about as we start to look at how we build this agentic hierarchy. So below that, we've got intelligent agents. This is a computational entity within agentics that's going to perceive the environment through sensors. We've also got agentic systems. These are complex arrangements of intelligent agents. So when you're looking at this, the point of this slide with all these big words on it is really that we're going to combine multiple intelligent agents into an agentic system that can deliver a better outcome. And I think one of the things you'll find with this is not only can you develop more quickly, can you develop more accurately and iterate more quickly because you're working in smaller chunks by building multiple agents together, but you're also able to better optimize your costs because you get to choose the models that make the right sense at the right cost points for specific agentic processes. And Reuven will correct me if I'm wrong there. Importance in modern engineering and AI. The foundations of modern engineering and AI, we have two big things we want to think about here. One is the integration of AI into engineering. How do we use AI to enhance or more rapidly develop or engineer what we're engineering? So AI can enhance our traditional practices and processes. It can enable things like predictive maintenance, system optimization, or automate processes. And then when we move further right, now we're talking about the intelligent systems, systems that can perceive, reason, and act, helping to improve decision-making, operational efficiency across engineering disciplines. So we're going from a base component and building that into an intelligent system. Now, the core components of intelligent agents are going to be an important piece of the next chunk of information. So as we look at this, let's start by talking about prompt engineering. Prompt engineering in 2 paragraphs is really the process of designing and refining the inputs, which we call prompts, that we're feeding into a given AI model. So you can see people getting paid to be prompt engineers. What they're really doing is taking the task we're trying to accomplish and breaking it down into prompts or input for the AI system that the AI system can better interpret and execute upon. It involves crafting questions or statements in such a way that it's going to leverage the AI's pre-trained knowledge. So it requires some knowledge of how the AI processes and its baseline training, and the ability to interpret the human requirements to translate them into those engineered prompts. So the core elements of prompt engineering are going to be basic logic and reasoning, which is something your frontal lobe is built very well for when you are willing to use it. It's data integration techniques. So how do we merge prompts with enterprise data to get context-rich outcomes? We need the ability to use unstructured prompts where we can allow more flexibility, provide creative input, and adapt to diverse needs. We need a structured approach utilizing a chain of thought. Tree of thought. So the way I always think of this, and I don't know if the example or analogy works for everybody, is if I'm training my dog and I'm training my dog to do a command like roll over, I don't start by training my dog to roll over. I start by training my dog to sit, which seems counterintuitive. But sit is the first command they'll learn, and then lay down is the next command they'll learn. After that, I'll teach them to go from lay down to roll over. As I repeat these tasks over time, I can switch to use roll over, which the dog's little brain parses as sit, lay down, roll over, and executes as one command. I'm engineering my prompts to the dog in a similar fashion that you're breaking down a structured approach to the AI prompting. And then finally, we need a schema and data design. We need to be able to understand how the data will be accessed by the model to provide the context so that we can get the outcomes we want. So when we look at the system, assistant, and user prompts, we've got 3 different types of prompts we need to cover here. First, system. It's going to set the context and the overall behavior. It's going to define the AI's roles, its capabilities, what the AI can do for us. It's not typically going to be visible to the end user. It might also establish the ethical guidelines. The assistant itself is going to help to guide the responses from AI. It can include some specific instructions when and where required. It may contain examples of things like templates for formatting the output of the AI prompting, so on and so forth. And then the user themselves is now responsible for the actual query or instructions. What do I need the AI to do that these assistant and system prompts will help on the back end with? This can be a question, a command, or a statement. It's going to determine the tasks that the AI need to take, and it may require some clarification as you prompt through to get your outcome. Next, let's cover RAG. So RAG is Retrieval Augmented Generation. From the basic acronym name, you can already figure out what we're going to be talking about when we're talking about RAG. We're talking about retrieving additional information to augment the generation of the AI's output. So retrieval might be multimodal. We're retrieving information from a diverse set of sources. It could be audio, video, text, any number of other sensor data you can think of could be pieced into that multimodal retrieval. We've got semantic search, looking through text and relevance ranking, being able to understand of all the answers I can pull up from my learning set, which are the most relevant. Keyword-based documentation retrieval, looking for specific words or phrases, specific system or pattern matches, and then looking through fixed data sets. We need the ability to augment that. So we need dynamic context integration with reasoning. I need to be able to bring that information in, layer it with the appropriate context for the operations I'm working on, and then I need to be able to apply some basic level of reasoning to that to be able to extrapolate or extract the information into new use cases. And then contextual blending of the retrieved info, making sure that I can compile all of the context correctly to a given piece of data or piece of information that's being processed. When we get into generation, the G in our RAG, now we're talking about multi-step reasoning with an iterative refinement. So we're going through multiple processes of reasoning and then refining based on the outcomes of those reasoning. We've got coherent native or coherent narrative generation with citations. So the ability to provide a coherent output in a narrative format and cite where that information is coming from. And then the ability to do things like direct answer generation from augmented prompts. Now, the prompt tactics, the learning approaches to this. How do we go about this? First, we've got zero shot, complex reasoning tasks without examples. You've got one shot, you've got adapting to new languages with one translation. And you've got few shot, solving novel mathematical problems with a few different examples. As we go through this, there are different tactics that may be applied to different outcomes you're trying to drive from your agentic models or AI systems. In some cases, you may need to use one or more of these tools to get the outcome you're looking for. As you're looking at these different outcomes and learning approaches, as you move up the stack or up the slide, you're getting an increase in the capability and complexity of what you're driving. So with zero-shot learning, the definition and mechanism, it doesn't require any task-specific training. Model is going to utilize its extensive pre-training on large data sets to perform tasks it hasn't been explicitly trained on. So you can think of this, the common thing that you might think of in this zero-shot learning is probably something like a ChatGPT, where you can basically go in and ask it about just about anything, and it can do a little of everything. So a GPT model is a zero-shot learning model. Example task here would be something like language translation without specific examples. Translate English to French. When we get into one-shot learning, now we're involving training the model with a single labeled example to enhance its ability to perform a specific task. So if I want to take my GPT model and teach it to ace the SAT, that is something I could go and do in a kind of a one-shot model. I'd use the specific ACT or SAT work to train the model in a one-shot learning fashion. So a prompt example would be translate the following sentences to French. The dog is playing in the garden, gets translated across. Reuven can probably say the French words because he is Canadian, and so I'm assuming there might be a little bit of French exposure up there in the cold. Prompts, few-shot learning. Now we're providing the model with a few labeled examples, allowing it to better grasp and perform the overall task. So this isn't the super directed one-shot learning. We're now giving it a few examples and allowing it to extrapolate or abstract what it's getting out of that. So GPT and few-shot learning examples here could be determine the sentiment of the following statement. And you give it a handful of examples teaching it, this one was positive, this one was negative, so that it can learn from the prompts to know what to do moving forward, or how to classify or label, analyze moving forward. So when we look at structured versus unstructured prompts, a structured prompt is going to have clearly defined inputs and specific instructions to expected outputs. Take this Word document I'm sending you and correct all the grammar and spelling, right? Very simple, low-level example that you can do without AI. But the idea being, here's my input, this is the output I want. It's going to be easier to evaluate and refine because you're very specific about what information you're putting in, what will be used, and what output you want from it. When we flip to the more complex side, now we're looking at unstructured or freeform. Now it's open-ended. It's allowing for more diverse and creative responses. So this can be something like, write me a blog on the future of telecommunications, right? There's a million ways that can come out. This is very unstructured and freeform, and it might need to be refined over time with more prompts after that initial output. So when we get into what is the difference, when and where would I use these, let's do a quick comparison. When we look at things that are very important to repeatability and troubleshooting, we've got things like standardization, error reduction, and scalability are all going to be better with our structured prompts. Now, unstructured prompts are going to reduce there, but what they're going to increase us on is things like creativity, flexibility, and ease of communication. So what you're probably already gaining is the idea that we're going to typically need to use a combination of structured and unstructured prompting to get complex results out of our AI and agentic models. So an example of an unstructured prompt. Here's an AI bot being designed to help CIOs develop and implement AI strategies, right? So this is going to need to be unstructured because we're looking at a strategic view of where the CIO should be looking, directing their attention and budget. This Unstructured prompt is providing flexibility. It's allowing for a more creative and flexible output. It's providing for ease of communication because we're writing it in natural language or communicating in a way that is native and natural to us. And it allows for a lot of creativity in a more narrative and descriptive style, which is going to allow for more rich and engaging content on the back end. But again, when that first output comes out, we may need to refine that more, and that refining might come in the form of structured prompts. So if we look at an example of a structured prompt, we're going to, here now we're looking at the ability to follow a standard syntax, ensuring consistency and clarity because we're defining the inputs and the outputs more strictly. We're getting a reduction in error because of those guardrails that the structured prompt is providing around the output. And we're getting documentation. Each section of the prompt will be clearly defined because we're structuring or breaking down that prompt into smaller bits, like the sit, lay down, and roll over example. So when we look at that and now we insert the next layer or chunk of information, we're talking about context management and memory in AI. Basically, the information about the information that it can incorporate and contextualize to do the job that you're asking it to do. Context management is the ability for the AI itself to understand and maintain the context of a conversation. We're talking about the weather and keep that thread of knowing that this conversation is about the weather so that I don't have to keep repeating the prompt that, hey, in regards to the weather, what is X, Y, and Z? Memory is its capability to remember previous interactions that happened historically, your preferences, and data that you've used in the past. And then we get into short-term memory. It's used to manage the immediate context, what's happening right now in real time within a single interactive session. We also have long-term memory, where it's going to retain information across multiple sessions so that we can, again, get back to that idea of more context about the user, how the user interacts, and the data the user works with. Context management and memory become extremely essential in creating these sophisticated and user-friendly AI systems. If your AI system can learn your behavior and understand your particular way of prompting, then it can better serve your needs as you prompt in that format. So for the 101 level of using effective prompts, up front, the first step is going to be concise and be direct. This is the information I want you to use. This is the output I want you to create from it. Clear and straightforward language, avoid unnecessary complexity. Provide any context that's necessary. Remember, you're talking to a tool that doesn't have all the information that you have rolling around in your head right now. It doesn't know your intent unless you tell it your intent. So if that intent requires some context, like the weather, if I want to talk about the weather, I probably need to talk about the location we're talking about the weather. I probably need to know which measurement system we're using for things like temperature. Are we like the real world using metric, or are we like those lonely Americans using Fahrenheit, right? Use examples for guidance in one-shot or few-shot learning. Give it examples of what the correct output is of what you're trying to get so that it can learn from that to provide you consistent results. And then finally, specify the desired format for the prompt response. You want this in a slide, you want this in words, you want this in a picture, tell it what to do. The more specific you are with what you need, the better the output you'll get and the faster you'll get to the appropriate output you're looking for. So the conclusion we're coming to here on prompt engineering, it's the art of crafting effective inputs for your large language learning models. It's a key consideration to include in the level of structured prompts and the learning approach used, because it is going to directly influence the interface that people have to the system. Effective prompts are going to be clear, concise, and they may include examples when those examples are required. Maybe you try it without example up front, and then you add examples for clarity to get the correct outcome. Overall, when you do this with these agentic workflows, you can enhance AI through self-evaluation and the refinement of the outputs you're getting. So agentic workflows are going to boost AI by merging self-review, the AI itself reviewing itself, the use of the tools that we interface with it, teamwork between you, the AI, and the AI agents, and adaptive planning. We get reflection, we get better tool use, we get AI collaboration, and we get the ability to drive better planning, as AI can become a source of autonomous planning and execution of steps to achieve complex objectives. So wrapping up, in your introduction to agentic engineering by this idiot before the real expert tells you how this works. Agentic engineering is about creating intelligent systems that are proactive, autonomous, and collaborative. They can do intelligent things for you on their own in a collaborative fashion with both the users and other AI agents, and they're targeted towards specific outcomes. We explored a bunch of different concepts and fundamentals of this, which I'm not going to belabor because I probably made it all up the first time. You now get your certificate of completion. So you can go ahead and download this, print it out, post it on a billboard somewhere, and let everyone know that you have learned from an idiot what RuV is going to teach you correctly. And now you can get in touch with not me, but Reuven.
There you go.
I like it. I think I learned a few things from my own deck.
No! We're not supposed to say those things around here.
All right. Sorry.
That was barely treading water. I'm like, I knew what I was expecting when Reuven roughed with the slides. I'm like, oh no. I'm like, can I even say agentic? Do I even know how to pronounce the word?
That was great. That's great. All right. Agentic engineering. Let's simplify this in the most basic terms. Agentic. What in the world? Sounds really impressive, right? It's agency. It's the ability to make software that runs essentially by itself. It has agency. It has the ability to operate with little to no human oversight. This presentation will give you everything you need to know to be at least knowledgeable in the subject matter of agentic engineering and agentic systems. All right, let's get into it. I'm Reuven. I've been doing this for forever. I've been sort of that guy that's gone from a geeky kid to an even geekier adult. I've been doing this pretty much my entire life. Highlights in my career involve I was one of the first beta testers for AOL in 1990. That gives you an idea that how long I've been doing it. I was the original designer for the Napster platform in 1999. One of the first advisors for Amazon. Briefly CTO at Microsoft. Don't let me get into that whole story. That's another presentation for another day. Doing a long time. More recently, I've been an advisor to OpenAI, and I very much enjoy this. I've come up with a whole sort of process. Not that I think highly of myself, but I named it after myself. It's called the RuV approach, and it allows you to sort of quickly and iteratively build applications. My specialty is in the ability to build complex agentic systems using AI. So things that would have taken you weeks or months previously can now happen in a matter of days or less. And when people are looking to me to build things, they're looking for me to build things that are of high quality and capability in an enterprise context. It means they need to scale, they need to be secure, means it needs to work well without the sort of threat of it falling down in the middle of a busy day. So the enterprise sort of level scale and capability is key to the things that I'm building. And a lot of that focuses on autonomous systems. My clients are big. I have a sort of a break between the largest companies you've probably heard of and academic space. I like the idea of giving back. So a lot of what I'm doing right now is working with a number of different educational institutes and running things like the AI Hackerspace every Friday at 12 Eastern to sort of introduce how to do these things and how to do these things efficiently and effectively. So I guess one of my other claims to fame, while I'm on the topic, is I produced nearly 6 million lines of code last year. I don't know what that breaks down to on an hourly or daily basis, but it's more than a human could possibly do. And that's thanks to the fact that I use these technologies to build these systems quickly, not only for my customers, but just because I like to do it. This is the sort of thing that I really, really enjoy doing, and I do it kind of anyways. It's kind of an added plus that I get paid to do it, to be honest. So let's jump into agentic engineering. Again, the idea of agentic engineering is the ability to create software that is operationally self-sufficient. It can run itself, it can adapt itself, it can scale itself, and it can include humans if and when there are considerations to put that human back in the loop. So the key of this presentation is knowing how to talk intelligently about intelligent agents. And by the end of this, between all the slides and information you're seeing, you should have a fundamental grasp of everything that's important for being an agentic engineer. So let's start with the introduction to agentic engineering. And I've broken this down into what I call the sort of PACT approach, and that stands for proactive, autonomous, collaborative, and targeted. Now, proactive, you hear a lot. It's anticipating what needs to happen before it needs to happen. And one of the benefits to a language model is the fact that these systems are sort of probabilistic. They can anticipate, much like a good chess player anticipates the move before the opponent makes that move. These systems can make a kind of proactive prediction of what needs to happen before it happens. Autonomous, basically, it can make those decisions and then take action based on those. Now, a lot of these systems don't sit independently. They need to work with other things. Those other things can be people. Those other things can be other agents. So a lot of the agents are very targeted in what they need to do. They don't need to do everything, but they need to do that one thing very well. So to do that one thing very well and be targeted, you have to have those other three sort of core tenets. And together, that really gives you the ability to have a system that can truly be autonomous. Now, because I like the idea of making this sound kind of educational, let's look at the origins. Agent, it has agency, and X defines the fact it's a field of study. Suddenly, the idea of agentics is not just some crazy thing that I dreamt up. It's a legitimate thing. Also, I'm working with various universities to help sort of educate students and others on the subject matter. So hopefully, if I'm doing my job right, this becomes a next big thing in technology. All right, so let's break this down a little bit. So if you're familiar with the concepts of autonomy in cars in particular, there's this idea that you can kind of have this different levels of autonomy within self-driving cars, ranging from no autonomy, I'm driving it myself, all the way up to fully self-sufficient. And what I wanted to do here is apply a similar structure. So when you look at this, you'll see in the bottom left-hand corner, in the bottom, basically, there's no autonomy, there's no collaboration, it's not targeted. So essentially, it's traditional software. And as you move up the stack, you get more sort of proactivity, autonomy, collaboration, and you start seeing things like personal assistance and advanced AI, and reaching a point where it's HAL 9000 on Space Odyssey, and it knows everything about everything that's ever was and ever will be. We're not there yet. So when you look at this particular slide, we're sitting somewhere in the middle right. So look at the area of like multi-step task. That would be like the O1 model from OpenAI that came out recently, and different sort of models that are able to sort of adapt and do a bit of reasoning, but they're not quite ready for general purpose problem solving. You still need to give them a bit of targeted sort of focus on what they need to do and why they need to do it. Now, when you're looking at implementing these types of systems, you have to look at it from a singular level. You have things like intelligent agents, and the intelligent agents relate to traditional types of RPAs or robotic process automation. These are systems that were sequential. They were defined, and they couldn't really go beyond sort of where their procedures told them to operate. So if something broke and it wasn't defined in their procedures, they kind of are stuck. Where intelligent agents are able to use the PAC process and say, well, it broke, and here are options I have available to me. It could be, I need to fix the code, or I need to escalate this to a person, or I need to spawn a couple more agents to help me. It has the ability to understand that it has other options available to it, and it can autonomously make those decisions, whether it's escalation or otherwise. Now, in an agentic system, you have a series of these intelligent agents that are all operating within that structure, both as a singular agent. My job is to just look at what the temperature is of an industrial system, or maybe it's to do a control or other types of analysis, but it's very targeted. But as a collection of intelligent agents, it makes up a much broader whole and can do a variety of things, both individually and collectively. So the ability for them to operate individually or collectively is an important part of this distinction, and that's where the agentic system really comes into play. Now, when you look at the actual agents, there are predominantly two different types of approaches you look to agents. One is systematic. Systematic agents are the idea that you have an agent that understands the system in which it operates. Think of it like an operating system. I need to be able to deploy software, or I need to monitor the characteristics of a machine or a virtual machine or what have you. That's a system. The other is more data-centric. I need to understand the structure of the information that I'm getting and make a sort of analysis or determination based on the information. So when you look at these, you start thinking about, well, is this going to interact with the information flowing from the system, or is it going to take action and use tools and execute based on that information? So when you separate both these into systematic or data-centric systems, you start being able to create more complex and systems that are able to understand the inputs in terms of sensors and data and other things. And when you look at engineering those systems, you're using a lot of the same sort of philosophies you'd see in traditional engineering, and even going back as far as things like, Ford and his approach to sort of creating factories, where he created a systematic approach to the manufacturing of a car. You're sort of taking a similar approach to the systematic creation of these agents in much the same way you might create a factory in a more physical sense. Each spot along the assembly line has a very particular use, and that gets passed to the next. That would be a sequential approach. Now, the benefit to computers and these types of technologies is you can take a concurrent approach. You can try everything all at once and then come back and take the best solution to the problem. Core components of intelligent agents. So it all starts with prompt engineering. And prompt engineering is the idea of providing the input of that information. And that input of the information directly results in how these systems operate. Now, a lot of times when you think about prompt engineering, you're thinking about the fact that you're entering some information and it's giving you a response, which is a form of prompt engineering. But a lot of the prompt engineering that goes into this is predefined. Here are the rules that you need to sort of work within. Here's the structure how it needs to exist. And here are some of the information that needs to be interpreted. So when looking at prompt engineering, you're looking at a few key components. You're looking at logic, reasoning, and comprehension. Logic being this concept that I have a series of actions and activities I need to do. And the reasoning is, why does that matter? Like, what are the things that result from that? And comprehension is, do I really truly understand what that information really means in the context of how this application needs to operate? Then you have the idea of unstructured and structured prompts. Structured prompts being, I'm just randomly throwing some stuff in there and letting the AI sort of figure it out for me. Structured means I need specific guidelines in terms of what it needs to do, when it needs to do it, and how it needs to sort of respond to it. And a lot of times you'll have a schema and other data systems that help you sort of define that structure. LLMs do a great job of taking something that's unstructured and making it structured. So often you'll have a multi-step process. The input might be unstructured, but there might be a middle step that structures that for the next step. And that could be a different agent as well. Now, at the very last here, we've got things like the system, assistant, and user. And these are important distinctions. The system is kind of like the core sort of, the 4 laws of robotics. This is why you exist. This is how you need to operate. This is always going to be how you operate. The assistant is basically, here's my response. This is, you've given me information. This is how I've responded. This is a list of things I've already responded to. And the user is essentially, here, I'm giving you information. I'm telling you what I want. And this is the sort of last step, or the input, where the assistant is the response to that input. So these all work in parallel to one another, but they're all sort of separate from one another, and they're the key parts of making these systems really work well. Now, retrieval augmented generation is the idea of taking information from various sources and inserting it into a sort of common flow, which we've just described. That common flow can be things that range from simple to complex, and you'll see that there's a level structure on the left-hand side. So simple things could be, just a fixed lookup, or a very basic prompt template, and other sort of completion processes. But it can be much more complex as well, including things that involve multi-step reasoning. Back to the O1 example from OpenAI, it has the ability to reflect upon itself during the process and say, is all the information correct? Does 2 + 2 actually equal 4? And being able to have a reasonable and thoughtful output to the information that's been put in there. Now, when looking at that, you're seeing things like 0 shot, 1 shot, and few shot. 0 shot really has no context. You're saying, tell me, but tell me the color of the guitar on the wall. Well, you never told me anything about the guitar, so I'm going to kind of make it up. I'm going to hallucinate. 1 shot would be, tell me the color of the brown guitar on my wall back there. Well, you just told me it was brown. It's a brown guitar. So you're giving it more information. Few shot would be, tell me about the Gibson guitar on the wall hanging in my office here just outside of Toronto, right? I'm giving it more information, more context, the ability to understand why and what's being asked of it, including examples of those sorts of things. So zero shot, again, is useful for, unknown sort of circumstances and just broad creative sort of approaches where you may not know what the response is, and you want to give it sort of the ability to understand or come up with a creative solution. But the drawback to a zero shot is it has a tendency to hallucinate those potential things depending on how you're asking it. So the more definition you give it, the less likely it is to hallucinate. One shot is gonna hallucinate a lot less because you're giving it more information, and few shot is going to hallucinate the least because you're explicitly telling it what you need and how it needs to understand that information. And so combining all these parts, you've got structured and unstructured prompts. Structured gives it even more structure into how it needs to operate, the steps it needs to handle when it thinks, why, how, when, all those sorts of things. Where unstructured is kind of like me blabbing, giving you all this information all at once. It's kind of being plopped in there and letting the language model kind of determine when and why and what's important. Now, when looking at that, you've got things like, where and why would you use that? Well, things like standardization. If you're doing the same process over and over and over again, you're going to want a structured prompt. If you're doing things that require creativity, draft me a blog post. Well, you may want to give it some structure. Like I don't want you to use the word realm or delve or revolutionary, things that make it sound like it's AI, but otherwise go crazy. Create me the content. Right, so you can use a kind of combination of these factors when going and doing that. So an example of that would be an unstructured prompt here would be, here's a pretty detailed prompt, but it's telling it broadly why it needs to exist and what it needs to exist for, but it's not specifically going into the details of how it needs to respond beyond just general guidelines. So it's like, you exist for this purpose, you exist to help CIOs, but it's not explicitly saying, well, don't say this. Don't ever, or giving you, I need to output in a certain structured form. Now, in this particular example, you have the idea of a structured prompt. This acts more like an application. It uses a syntax, uses a structure, and says, here's exactly how you need to think. Here's what the features of the system. Here are the sort of confines of how you need to operate, but you can't operate beyond it. This is explicit, it's specific, and can't be done beyond anything that's defined. So the content management and context allows it to remember what's important. And referring back to the previous slide we just covered a moment ago, you have the ability to use, again, the system prompt, the assistant prompt, and the user prompt. The first two allow you to define memory or context memory. So, for example, you could give a very defined structure to the user prompt or the system prompt, but you can also go in and define other sort of capabilities and characteristics, and allows you to sort of say, well, this was already described, this was already defined previously, therefore I need to know that this is important. Be concise and be direct. The better and more explicit you are in the prompts, the better they're going to do. And so when looking at prompts and prompt engineering, the more detail, the better. I'm going fast here, guys. All right. Conclusion of prompt engineering. And I apologize. I don't think I can go any further. I think I might be void in this, but I'm out of time.
I will say, I know you're over on time, but this is the easiest decision I've ever had to make on this show.
Yeah. No, I mean, look, Reuven won. I don't even need to judge. That was brilliant. You should reach out to Reuven for more time. We have a hard stop.
I think, Joe, you did the best job I've seen. Like, your presentation was actually dead on. You did a really good job of actually providing the information. Your BS was not even BS. It was great. Yeah. I think I think anyone who just watched the first half of this will learn something new, and that's impressive.
Well,
awesome. Well, I pulled it out of my butt this time.
It worked. It worked. Well,
all right.
Thank you, Reuven. We've got to have you back. This is fascinating. Thank you.
Next time we schedule 2 hours, okay? I cut like 5 or 10 slides out of the deck. Sorry about that.
And for our audience, Reuven is all over the place. If you need to get in contact with him, we'll have his contact information attached to the show notes, or you can get a hold of me and I'll get you directed to him. But I cannot recommend the man enough.
Great.
I appreciate for including me. This has been a blast. I love the format, and till next time, I guess.
Till next time. See you soon. Bye.
Thank you, everybody.